Okay, now just now we stopped at how to find your y prime with two equations on the screen. Now we're going to find your x prime. What is x prime? Oh. So where is x prime? If you look at the screen, so just now we find your y prime. We already derived how you find this component. And now we need to find what is this component. Where is the location of your x from your x axis here? So you want to find derive equation to find your x prime on the screen here. The combination of x and y prime will give you a location of your fr that will create a moment that will create an effect of moment, or there's a motion to the plate. So the first equation, again, we use the same similar equation. How you find the moment in x direction? So you imagine you have a force over here, and then you swing from x bar, right? X prime here. So if you have yep, so the first equation is a moment from x here, from your x location. So x prime, let's say over here x prime. So here to here x prime. So you have a force on this location, you create a moment. Yeah. So we just expand this equation. We know that integration of A to pressure and area, you get your Fr. Fr times the x, you get the moment also. So again, this is a fundamental equation that we will use to derive our x prime. So once we solve for the right hand side, then we move our Fr to the right hand side. Okay. The similar process. So again, we write x prime Fr equal to integration of your xp dA. Substitute your pressure. Again, pressure P equal to P0 plus rho GH. So we'll consider the reference pressure or atmospheric pressure in our case first, right? So it will become this term. After that, you further expand what is your H. What is your H in Y term? So your H here on the screen on the left hand side, H you refer to the Y position here. You know that your H equal to Y sine theta. So again, you replace your H to the Y sine theta here. After that, you expand the equation. You times your x inside there. X times PO, you get the first one. And then your x times the second one, you'll get rho g xy sine theta. Previously, when you find your y, you get y squared here. But now you will have xy term here. Okay. So this is all mathematics steps here. Yeah. So make sure you understand why suddenly here there's a xy. Because you replace your h, so h equal to y sine theta, and then you times your x inside the equation, you'll get a xy term here. And then you rewrite your equation into two terms. One with integration of a x dA plus rho g sine theta integrate xy dA. So again, you're seeing first moment and second moment equation here. First moment, second moment of area. Yeah. And just as a note, remember to download the appendix that we put on the Moodle. So go have a look. There's an equation to find the first moment of area for different shape. Okay, once we have the first term and second term equation, we recall the definition of the first moment equation and second moment equation. So first moment equation just now, integration of x dA we can write as x over centroid, the location to the centroid of an object, okay, times the A. The second one is again is the second moment. In this case, since we are looking at xy component, so our second moment notation, we write ixy. So there's a formula to calculate ixy also. So I put on the screen here. We will use parallel axis theorem that we can write ixy equal to I through the centroid location x bar or x head xy plus ax centroid to y centroid. So this is a parallel axis theorem that we derive for a second moment of area. All right, this one should already cover in the static or dynamic chapter. Okay. So you rewrite the equation on the screen here, the first equation here. The equation will become P0 xc or x at the centroid times A plus rho.g sine theta, and the second moment equation we rewrite without the integration form, we can write as ixy plus ax centroid y centroid. And then you further group them together. The first term where you group the A and X centroid together. And then the second one is the second moment around the axis. So you have XY hat here. So far, we rewrite the first equation in terms of centroid X location and IXY term. Yeah. So each one of these you can calculate individually, X centroid and also IXY according to the appendix. Yeah. So centroid, how you find it? Also, there's a chapter in static to find where is your centroid. Yeah. So you can further simplify where we know that y centroid sine theta also is a height to the centroid. So we further reduce the equation in the h centroid here. Okay, so if you want to draw on the free body diagram or where is the centroid is that let's say this is your centroid C. So HC is here. This is your HC. Okay, let's say this is your centroid. If you expand to the XY plane, so this is your centroid. Okay. Then recall the definition of your resultant force. Resultant force equal to P0 plus rho.g.h. In this case, is through centroid, H centroid. So we have this equation for your further derivation. And then you rewrite the equation in x prime. You pull your FR to the right hand side. So the first term you cancel. So you both sides you divide by FR. So the first one cancelled. Left side also cancelled. So only left out the second one, you have FR here. Okay. So that's why the first one, hold on, there's an A there. Let me see here. Why my A is missing? I think my A I forget to include here. There's A missing here. Hold on, where's my A? There's a A missing. Let me see the previous Y slides. Okay, I owe you an answer. Where from these slides to another slides, the A is missing. Yeah. So the equation here, x prime equal to x centroid plus rho g sine theta I second moment of moment divided by Fr. So the equation on the screen here is F naught, which include the P equal to P0 plus rho GH. So again, if we have a case where we ignore the reference pressure effect, which is P0, then we will use gauge pressure. Yeah. If we ignore, if the question stated we ignore the P0, then we will use the P gauge here for our FR. So if we substitute rho g hc, because the P gauge equal to rho g h through the centroid, then you'll get the second equation, which is on the screen here. And this equation at the bottom of the screen here is when we ignore the P0 effect. Yeah. So again, the top equation here, if the question asks you to calculate or only consider the force acting on top of the plate, then you use the first one. If the question asks you to consider the P0 on the top, and it also state that the P0 acting at the back of the plate. Also, if you consider both effect of the P0, then you use the second one. Okay, use the second equation. Okay, the tutorial question we will discuss in our next class. Let me check the equation Anything that I miss out? Okay, I'll come back with the A term here, because if you take out the FR, your A should be there, but not sure. Okay, I'll come back with the answer in our next lecture. So today what we have covered is we have two equations. One is your y prime, the top one and the bottom one, these two, and your x prime or x location for your resultant force of your FR. So we have these two equations. So each one give you a different consideration. So be careful when you use them. Yeah. Okay. So let me stop the recording.